One of the absolute best games to release this year was Half-Life Alyx, the long-awaited return to the groundbreaking Half-Life series. As is the case for all games, immersion is the cornerstone of any great experience, and especially so with games designed for virtual reality. Game developers must focus even more on keeping players immersed in their experiences, and even the smallest mistake can break a player out of the world they have been placed in. One of the most immersive and polished experiences of the game is an area where you have a run-in with a blind zombie nicknamed Jeff. While Jeff may be as blind as a bat, he most certainly has a great sense of hearing and will pick up on any sounds that you may make. And while you may be able to avoid making much sound yourself, there are lots of things in your environment that can create sound, such as squeaky door handles or precariously placed vodka bottles. As you are travelling through a vodka distillery, you can pick up and throw said bottles of vodka away from yourself to try and distract Jeff. I absolutely love how immersive this mechanic is, and it has created perhaps the most engaging and horrifying experiences I have ever had in a video game. But enough of my gushing about Half-Life Alyx. Let's talk about what we can learn from it and apply those lessons to our Unreal Engine tech demos. Because audio is one of the most important factors in helping us to create more immersive experiences, designing gameplay around it can help us to engage our players even more. My name is Matthew, and in this video I'll be explaining how you can improve the AI enemy from our Week 5 lab by designing and implementing an audio detection system like the one that Jeff uses. While we won't be making our AI enemy blind, we'll still be taking a bit of inspiration from Jeff and giving our AI some ears. To let it be able to detect sounds from the level around it, we'll need to look at how we can extend the AI perception component we have already added to it, as well as think about how we can use the AI manager to tell our enemy if there is a sound close to it that it should know about. There are a few main sections to this video. Firstly, we'll have a look at how to architect a noise notification system. Next, I'll show you how we can extend the existing finite state machine to allow the AI to search for the player. Then we'll go over our implemented code. And to finish, we'll have a think about how you can extend this system for your own games. If you are interested in following along with this project, you can view our source code here on GitHub. When first building any system, we should always think about how it will all fit together. Let's identify all the parts of our audio system that we will need. We have our audio sources, such as gunshots, our existing AI manager, and our enemy AI. In our implementation, we have decided to add a noise notification actor class. This class has been designed to make it simple to pass a sound event to our AI manager. In our AI manager, we'll need to create a new function that can pass in the sound's position vector and float volume. This function will then be able to check if the sound's position is near to the enemy AI and if its volume is loud enough for the AI to hear. Moving on to our finite state machines, let's do a quick recap and go over our existing state machines from the lab. In this state machine, we can see all the pathways between our AI's various states. As you know, our AI moves around between nodes and continuously checks if it should be updating its current state according to this graph. This is a great starting point for us, and we'll need to add just one extra state to our AI in this video. Because we have designed our audio system to tell our AI where a sound happened, we'll want it to go search in that area and try to find our player. We'll want to create a new state called search, which will let our AI move towards the last known sound location that they were told about by the AI manager. To enter the search state, we'll want its only entry point to be from the patrol state, as we want it to search for the player while it's on patrol. It should also be able to go back to the patrol state if the player was not found at the location it has gone to. Finally, we'll want our AI to be able to engage the player if they have been found while the AI is searching for them. We will also want our AI to be able to evade the player if the AI has been attacked while searching. So let's have a look at our noise notification system. And if we open up in Visual Studio, we can see in our header file that we've created a couple of different properties here. The most important ones to think about is obviously our reference to the AI manager and a blueprint callable function called onAINotify. And what this function does is takes a parameter called noise position and volume, obviously passing in where that sound happened, and we can call a function on our AI manager, notify agents. And if we have a look at our AI manager, you can see that function there. And what this will do will calculate basically a volume distance. And if, when we're looping through all of our agents here, the distance squared between the position of our agent in this loop and the noise position, if that's close enough, we can update some data on our agent, which we'll talk about more with our finite state machine. Okay, so let's have a look at our finite state machine. The first part, if we come into the header file for our enemy character, is that we have added a new enum here called search. And what we want to do is when we are looping through and going through all the cases for current agent state, we get to search, and there's a couple of important bits before we even get to that, where we want to update our agent state in our AI manager. So when the AI is close enough to a sound, we set this agent state to search. The agent has a variable called last noise position, and we pass in where that position was, and we empty their path so we can start calculating that. Going into the enemy character, we do agent search. We come down here. If the path is empty, we can find that nearest node to where the sound was and navigate to that. And if we come back up to search, if it can see the actor, it will break out and it can either go to evade or engage. And if at this point the path is empty again, it can exit the search state and go back to patrolling. Okay, so if we come into our enemy character blueprint, we can see here I've extended the AI perception config, and I've added on another sense that uses AI sense _ hearing. Now, what this allows us to do is to detect if any sounds have been detected in the built-in UE4 system. Now, you're probably wondering, well, why did you build a noise notification system? Well, the thing about this is that we're not actually using it, but it helps us to distinguish between different types of stimulus sensors. When we look at our sense player function that we've implemented in our labs, we're able to update B can see actor, which you would already know. However, if we just want to directly use that, it won't work for the other states, and it will break. With the onAINotify function, we have created it as blueprint callable, so that when we come into our player character blueprint, and only our player character blueprint because we don't want the AI to register its own sounds, we can call off on the fire, and we can call onAINotify with position and volume, as well as report noise event for target AI sense hearing, so that our enemy can detect it. There are lots of different ways you could extend this project. We ourselves have added some bottles. This was done by Nikki, and you can see here we can crash into them, they break, and that does also make the enemy detect it. There are lots of other ways to extend a noise system within a game or within this project. Some of these could include having multiple AI and only sending the closest AI to investigate noise, or you could even add just more sound sources, things in the environment that could alert the AI, or you could allow the AI to stop and wait around an area where it heard a sound, or just like Jeff, you could only allow the enemies to detect you through sound. And there are lots of other interesting possibilities, of course, so I can't wait to see what everyone else has made for this assignment.